Hello everyone. Yes, this moment I want to share you how to solve some question in physics paper 2 as structure question. This is on October November 2008. Yeah. Okay, we will continue about how to solve this question. But before using my video, don't forget to subscribe, like, and comment on my video. Yes, go to the first question. Number one is the current is in wire is I, charge Q passes one point in the wire in the time t. State the relation between I, Q, and T. Okay, the I Q over T, yeah, because the current equals to charge over time, yeah, because current equals to charge over time taken. Yes. Then question II, which of the quantities I, Q, and T are base quantities? The base quantities is only I, this is current, yeah, in ampere, and T is in second. Yes, this is the base quantities. So question B, the current in the wire is due to electrons, each with charge Q that move with speed V along the wire. There are n of these electrons per unit volume. For a wire having a cross-sectional area S, the current I is given by the equation I equals N S Q V power of K, where K is a constant. State the unit of I, N, and S, Q, and V in the term of base units. So, I actually, the unit of I is an ampere. Yeah. Unit I is an ampere. And N is this electron per unit volume. So this is amount of electron per unit volume. This is around meter minus 3 because over meter square, yeah. So we can call is the m power minus 3. And then S is a cross-sectional area. So on the cross-sectional area, it's mean as the area, so we can say this is M2. So Q is charge is in column. Yeah, let's say this is about column is equals to, if we see Q equals to IT, so Q equals to ampere second. Then V is velocity or meter second minus 1. So by considering the homogeneity of the equation, determine the value of K. If we see I, let's see on the question, yeah, N equals to meter minus 3, and S is meter power 2, and then Q ampere second, and then V is meter second minus 1. So if we see, we can say we can cancel this one, for the meter is cancelled, and second also we can cancel. Yeah, let me see, I equals to ampere. Yeah, ampere, yeah, that's, yes, correct. K equals to 1. Yeah, K equals to 1. Sorry, yeah, K equals to 1 because we can cancel it. Second minus 1 also second, yeah, we can cancel it also. So we get K equals to, I equals to ampere, yes, K equals to 1. So continue to the next question. Oops, sorry. Yes, here. A car traveling along straight road at speed v, a hazard suddenly appears in front of the car. In the time interval between the hazard appearing and the brakes, the car coming on into operation, the car moved toward a distance 29.3. With the brakes applied, the front wheels of the car leave skid mark of the road that are 12.8 meter long, as illustrated figure 22.1. In this estimated that during the skid, the magnitude of deceleration of the car is 0.85 g, where g is the acceleration of free fall. A. Determine the speed v of the car before the brakes are applied. Okay. We will see on this position car traveling must although this done with okay. So if this position is stop the car, so we have formula that v square equals to v times square equals to v square minus 2as. So this is coming to stop, and this is v square minus 2. A is 0.85 g. Let's say g is 9.81, and distance is 12.8. So we get v square adalah here. So we actually, if we use calculator, two times with 0.85 times 9.81 times 12.8 is coming 2, and then we root it. Yeah. Answer. So this is about 14.61 meter second minus 1. Okay, we get 1461 meter second minus 1. Then continue other question. The time interval between hazard appearing the brakes being applied. So we will find the time taken after 12.8 meter with velocity 14.61. We can use about, sorry, we have time, yeah. Let's say we have s equals to vt. Oh, no. We can use, sorry, we can use v equals to vo, because this is coming up from coming to stop it, and v equals to 14.61 and minus a is 0.85 g, let's say 9.81, T, so we get this is, but let's say we calculate 0.85 times 9.81 equals with, yes, and 14.61 divided by answer, that's equals with 1.75 second. The T is 1.75 second. Yes, that's the answer is. Okay, continue to the next question. The legal speed limit of the road is 60 km per hour. Use both of them under A common standard driving curve. So if we see 6 km per hour, it means, yes, velocity is 60 km per hour. It means times with 1 kilometer is 1000 meter in this is second. So this is actually something with let's say we cancel this one, yeah. So this is something with 600 divided by 36, yes, 16.66 meter second minus 1. What do we call it about the 16.66 meter second one? It's not longer than, because the maximum speed is only 14 point, sorry, the maximum the speed is still on the 14.61, so this is less than by for 16.6, yeah. So this is a standard of driving of the car. Okay, so question 3 is distance between moment force and torque of the couple. Yeah. Actually, moment of force is equals to force time distance. Yeah. Torque of the couple is force time distance, but this is a lot of force of time distance, so more than one, yeah, like this one, this is like this one, this is 4, and this is d, yeah, force, this is one of them. But only moment of force, only F times D, only one. This is about the theory, about the fundamentals theory of torque, yeah, fundamental moment of force. So B, one type of weighing machine known as steel yard is illustrated in figure 3.1. Yes, the two sliding weight can be moved independently along the road. With no load, the hog the sliding weight at 0 mark and metal rod. The metal rod is horizontal. The hog is 4.8 centimeter from the pivot. A sack of floor is suspended from the hook in order to return the metal rod in the horizontal position. The 12 Newton sliding weight, yeah, move for 84 centimeter long rod, and 2.5 Newton weight move 72 centimeter. Okay. So the question is calculate the weight of sack of the floor. Weight the sack of the floor. Okay, we see this first. Let's say this is sack of the floor. Let's say this is mg, and $12 Newton sliding weight into 80 along the road. So this is coming 84. Yeah. This is 12 Newton and 84 centimeter, and along road to 72. Yes, here this is along 72 centimeter, 2.5. So if we want to find the subfloor, yeah, let's say here I want to calculate in this position, yeah, in this here. So we can say about the mg times 4.8 centimeter equals with 2.5 times with 72 plus 12 Newton times with 84. Yes. So we can say this is about the let me calculate about these numbers. Yeah. I will calculate this also. 2.5 times with 72, it's around 180 plus 12 times with 84, means 1008. And then if we sum the 1, this is coming 1188. This is about mg. So m, let's say this is divided by g is 9.81. Sorry, g is 9.81 and times with 4.8. So we can say this divided by 9.81 times with 4.8. Yes, we can say 25.22 kilogram. 0.22 kilogram. Yes, this is the mass of floor. 25.22. Actually, we can 25 kilogram here. Suggest why the steel yard will be impressing with object with the weight of about 25 Newton. Yes, because yes, if we see the number of 12 and 2.5, yeah, this is about, if you do times of this, it is around 25 Newton. Yeah, 25 Newton. This is a half of this root. Oh, this is weight. Yeah. About weight, actually this is around, if we times with 9.81, so we can say this is on the Newton 247.5 Newton. Yeah. Okay, we see on the next page. Okay, number 4. This is about the two parallel plates P and Q are separated by a distance 7.6 millimeter in vacuum. There is a potential difference to 150 volts between the plates, as illustrated in figure 4.1. Electrons are produced at X on the plate. Thus, electrons are left from rest to travel to plate Q. The electric field between the plates may be assumed to be uniform. Okay. Determine the first electron with the electric field. Yes. Determine the force an electron do the electric field. So force, yeah, equals with QA. This as Q electron, yeah, charge of electron times of electric field. That Q electric field means V over D. So we can say this is 1.6 times minus 19, and V equals to 250, and divided by D is 7.6 millimeter minus 3. So we can calculate this one by 1.6 times 250 divided by 7.5 here. This is around 3.33 times minus 16 Newton. Okay, we can say 5333 times minus 16 Newton. Okay, continue. Other question is, so that the change in kinetic energy of electron as moved for plate P to Q is above. Okay, change kinetic energy, it's mean work done. Change kinetic energy, it's mean work done. Work done, it's mean F distance. So if we see F distance, so we can say here is force 3.33 times minus 16, yes, times with distance is here. This distance is here 7.6, yeah, 7.6 millimeter. So times with minus 3. So we can say this times with 7.6 equals to actually 405. 405 times 3.3 times with minus 90 joules. So we can say this is around 4.0 times minus 70 joule. Yes, this is the same thing as this one. Okay, continue to the next number. Determine the speed of an electron as it reaches plate Q. We know this is about the kinematic when B final equals to V initial plus 2AS. Because coming from rest, so VO equals to 0, then 2A is force over M, S is distance. So we can say this is 2, force is, we have already know force equals to 5333 minus 15, sorry, 5 minus 15 divided by mass of electron is 9.1 times minus 31, and distance is separate of two plates is 7.6 millimeter. 7.6 millimeter. So we can calculate this one by, let's say, 2 times with 5.33 times with 7.6, yes, divided by 9.1. So we get 1. This is 1.9 something times with let's say minus, this is minus 18, 31 minus 18, 12, oh sorry, 31 minus 18. 13, yeah. This is 13. So if let's say this is if we use 9 times 12, yeah, so we can say root of yes 9.4. Yes, this is 9.4 times 6, yeah, meter per second. Yes, this the answer is okay. The position of the plate are just so that the electric field between them is not uniform. Yeah, the potential difference remain unchanged. So state they explain the effect, if any, of this adjustment of the speed of electron as it reach plate Q. Okay, okay. This is about the force. This is actually velocity is depends by acceleration. Then acceleration coming from force over mass, and force is qa, and a is volt d. So we can say state explain speed of this electron, yeah, is depends by d, so it will be effect of this, yeah, so it will be bigger than before if d plus adjusted electron. Yes, yes, it will be effect because d is because we depend on d, because velocity depended by distance of two plates. Okay, I think enough for this session for explanation for numbers, yeah. Thank you very much for watching my video. Don't forget to subscribe, like and comment, and see you on the next video. Thank you very much.